on to this subtopic under kinematics, horizontal motion. Now we did vertical motion and gravity where objects are thrown up vertical ladders. Now we are going horizontal motion this way. No more this. No, we're going this way. Horizontal. Good. Now if a particle is projected horizontally at a point above the ground from here, the particle travels through a horizontal distance x and a vertical distance y. In which sense? Horizontal distance s, vertical distance y in which sense? When you're coming down like this, because I'm not the vertical. You see, if you're moving like this, right? Then you have to fall. You can throw this marker horizontally this way. You get to a point where it has to get fall. At that time, it is obeying the vertical distance. Are you getting it? How does it now? The time taken to travel through the horizontal distance, the same time taken to travel through the vertical distance, yes. The time you spend like this is the same time like that. The particle has no initial vertical velocity. Take note. I threw the particle from here, horizontally. At that time, the particle have no initial vertical velocity. The particle rather has what we call initial horizontal velocity. Are you okay? You get it, right? Good. So it has no initial vertical velocity. That is it. Point right. The initial horizontal velocity is the same throughout the horizontal motion. Horizontal motion is given by initial velocity. That is the initial horizontal velocity times the time. Now let's see some application. This is also a wide sample question. A particle is projected horizontally. A particle is projected horizontally from the top of a tower 20 meter high. That's the height. Calculate the horizontal distance traveled by the particle when it hits the ground. I was giving gravity. Now, why did you give me gravity? We are talking about horizontal motion, whereby the time taken for the particle to travel horizontal is the same time for what? Or the distance to travel horizontal is the same distance for the vertical. So they gave me gravity. Because when you throw something like this, gravity should cause it to fall. So this acceleration cannot be a uniform acceleration. Are you okay? That's why gravity was given. Because when you throw something like this, that's horizontal motion. It gets to a point where it ceases and starts falling. Is that not gravity? No. Now let's continue from here. Now, calculate the horizontal distance traveled. Okay, I have h, I have g. I think I can use this equation of motion using s equals ut plus half at squared, right? But since we are talking about vertical motion and gravity, I'm using this half gt squared. So even in this horizontal motion questions, right, we have some books who have formulas for them, right? We have some formulas for them. I don't need to write all those formulas for you. I can help you to just write them yourself. Now the particle has no initial vertical velocity, right? U here is 0. Why? No initial vertical velocity. No initial vertical velocity. How did I know? What if somebody says, okay, sir, I want to use this formula? Then I will still call this my 20. No, it was only given as 10, right? So I want to use this formula, then I'll still call it my 10. As you can see, so U is 10. That is what horizontal velocity, right? I'll still call it my 10. Okay, let's see. If you still want to call it your 10, can't you see the question itself tells you that the solution is J? So the formula you are seeing, right? The initial vertical velocity is U. Not that. You only use this when you get to this formula. Are you okay? So take the velocity given in the question is not this vertical velocity. It's an horizontal velocity. But the particle is projected horizontally at that is the horizontal speed. Right? And does this formula look like a horizontal formula? Is that not vertical motion and gravity? Oh, so be very careful, okay? So the formulas are derived like this. I'll give you a formula like this. S Then they will make it h equals what? G in t squared. Do you know why? If this is 0, everything here will be 0, then you get this. You find another one like this. Watch. So this is not 0, right? So they'll just get what? G in t. And then you find another one like this. This is 0. Right? So you get 2gh. So these are the 3 equations for what? Horizontal motions. Why do you have to go through all this? Why? Just understand the concept. You don't need to put all these things in mind. No. So that's it. So we have 3 equations. So when you are working, students have to learn all this before they go. No, you don't need it. Okay? You don't need it. So these are 3 equations. You see them in books. Good. So height 0 by t plus half 10 by t. Do we know t? No. Do we know h? Yes. That is what? 20. So 20 equals what? Half by this will go here 5, right? We get 5t squared. So how do you divide through by 5? Why? I want the t to stand alone. This is 4 equals t squared. Remember the principle here? So root of 4 is what t. That's plus or minus what 2. So this is 2 seconds. You don't have a negative time. So we take the positive. But in natural sense, it's always plus or minus enter here, right? So I have the t 2. Now, what would be my horizontal distance? So let's look at it. My horizontal distance is the initial velocity. That happens to be the initial horizontal velocity times the time. The initial velocity is what? Time. The time is 2. This will give me 20 meters. Yes, that is horizontal motion. Take note. The velocity is given a horizontal velocity on their own. So vertical initial velocity, remember, is 0. 0.2. The particle has no initial vertical velocity. Okay? It had a velocity when it stood in the drawing before we projected it horizontal. Okay. You're welcome to the last part of motion or kinematics. Projectile. Now, what is a projectile? A projectile is a particle which is given an initial velocity and then allowed to move freely under the influence of gravity. So this is not projectile. No, it's not projectile. Projectile is when you give it an initial velocity, right? You give it a speed. So this is not projectile. This is projectile, right? So you give an initial velocity and allow it to fall freely under gravity. Analysis of motion. So consider a particle projected with an initial velocity u at an angle alpha to the horizontal. What do you see here? There's horizontal, there's a vertical. And has a velocity v at time t. Good, there's time. So okay, there's a y-axis here. Okay, taking the origin as the point of projection here, origin. OX being the horizontal axis. OY vertical. Okay. Now the time of light. It is the time taken for the particle to travel along its path from O to A. So from here down to here, the time taken is the time of light. Now there's a formula. 2 by the initial sine alpha over g, gravity. Time taken to reach maximum height. Time taken to reach maximum height. That's the formula here. Now range. It is the distance traveled OA by the projectile. You see projectile, so O, that's a range, right? Range. Good. Now the range is maximum when sine 2 alpha is 1. You see, when alpha here is 45, 2 times 45 will give you 90. Sine 90 will give you 1. So they can ask you, which value of alpha will make the range maximum? That's 45, right? So sine 90 will give you 1. Or sine 2 times 45 here will give you 1. Now let's apply what we have studied. Now greatest height. the projectile reaches its greatest height when the vertical velocity is 0. This is the formula for greatest height. Now let's see an application here. Let's look at an application here. We have our formulas on this side. And there is our question, right? A particle is projected from the ground level with a speed of 20. With a speed, that's initial velocity. Initial velocity of 20 meters per second. At an angle of 40. That is the angle alpha. 40 degrees. The time of flight. So let's come here. Time of flight is given by 2u. Go. Now, so let's go. So there is a t, time of flight. 2u sine alpha over what? G. Now 2. What is the u? 20. Sine alpha. That is what? 40 over gravity. So gravity will be given in the question, right? Take acceleration due to gravity. Take J to be 10 meters per second square. That's 3, 4. So there's 10. Now, please point to this answer. So what are you getting? Oh, system. What are you getting? Seconds. Okay? Good. Now the range. So range. It is u squared sine 2 alpha over g. U squared sine 2 alpha over what? Gravity. Now, u squared is 20 squared. The rest of you, where are your calculators? 2.5. So 2 by 20 sine 40 over 10 will give you 2.5, right? Seconds. Good. Now the range. U squared sine 2 alpha over gravity. Now u squared is 20 squared. Sine 2 alpha over 10. Now just put them together. Punch. So we have 55.8. Range is a distance. So I'm supposed to be getting 55.8 meter, right? 55.8 meter. Good. Now, the time taken to reach the greatest height. I'll give you the formula for that. Time taken to reach the greatest height. That's I. T equals u sine over what? So u is 20 sine 40 over gravity. Yes. Alright then. 1,285. And then seconds. Now the last one. The greatest height. That's the formula up there. That's pi maximum, right? You have u square sine square alpha. Please watch here. You see sine square alpha. Note. Sine square alpha is the same as you writing sine alpha all what? Sine alpha all square. Let me put it this way. Sine alpha all square. Okay. You can't point sine square alpha. No. develop upon sine alpha all squared. That is the representation. Okay, so let's go. So y maximum equals 20 squared by sine 40 whole squared. As I said here, all over 2 times the gravity. Yes. What are I getting here? 8.3. Maximum height. That is meter. Good. Tennis ball projected at an angle theta attains a range of this. So the range has been given as 78 meters. If the velocity impacted to the ball by the racket, so when the ball comes in, it's right, that's a projectile. So U is 30 meters per second. Calculate theta. Gravity is 10 meters per second squared. So I will put the formula for range. U squared sine 2 no more alpha reduce theta, okay? All over G. All the formula is right. This is the range formula. Now the range happens to be 78, as you see here. U is 30 squared sine 2 now enter this way. The angle is theta, right? Sine 2 theta, okay, all over 10. So we have to cross multiply here. You see that? So I have 78 going with 10. 30 squared is 900, right? Times sine 2 theta. Now this will give me 780, 900 times sine 2 theta. So you see, this is the trigonometric ratio, and then is the angle. You're going to deter this angle from this ratio, and you're using the concept of inverse, sine inverse, cos inverse, right? The trig inverses. So I have 780 equals 900 by sine 2 theta, all over 900, all over 900. Sine 2 theta equals 0.what? 8660. 8667. Good. Now I have sine 2 theta here, right? Good. Now, if you have sine theta like this equals 4, and you just want this angle theta, it will be the sine inverse of what you see on the other side, okay? So that is how we detach a ratio, an angle from a trig ratio, right? Okay. So let's consider all this as 1 now. So I have 0. So let me rewrite it. 0.8667, right? So 2 theta is sine inverse of 0.8667. So take note. So let's go. 60. Now 1 theta, right? I have to divide through by what? 2. Now theta is what? 30 degrees. So this is the angle of projection, right? 30 degrees.